Hey, my name's Brent. Welcome back to 49cc Scoot. Today I'm going to be checking out the Firstess MP200 made by YesWelder. This is a 5-in-1 multi-function machine. It does MIG, Flux-Core, MMA or stick welding, TIG welding, and in addition it even includes a plasma cutter. So I'm pretty excited to check it out. Before we get started, I want to make it known that YesWelder provided me with this machine at no cost. I haven't really been paid, but I don't have to pay for the machine. It was delivered to me, and I didn't even have to pay shipping on it. So first off, thank you to YesWelder for giving me the opportunity. What they're doing is they are launching the Firstess MP200 on Kickstarter, and they're looking for a lot of feedback from the community. And they're looking for feedback from professional welders and people that can make videos. So I can make videos, but I'm really not sure what I'm doing here being lumped in with professional welders, because to be honest with you, I've spent quite a bit of time messing around with my own Flux-Core welder doing personal projects. I do have a MIG machine, but I've never even used it on MIG. I've got a TIG machine that I have very limited experience and time on, and I also have a plasma cutter that I have very limited experience with. Actually, both my TIG and my plasma cutter are YesWelder machines. So I'm happy to be here and happy to be given the opportunity to do this, but I'm guessing they've got me here as the novice that maybe some of you guys can relate to. Whatever the case may be, first thing I'm going to do is go ahead and unbox this. Actually, before I tear into this box, I did want to show you that there are some specs on the side of it. Maybe those will be of interest to some of you. I do want to let you know, though, that I have been made aware that this is a beta machine that is being provided to me, and there may be changes in the final product. So I'm not 100% sure that all of this will be exactly the same, but this is what I'm looking at. There's certainly a lot of stuff included in the kit, so let's take a closer look at some of it. I'm going to start over here on what I would call the boring end of this little arrangement that I've laid out. So this is the stuff like you've got your wire brush, your cleaner here. You've got this adapter. This machine will actually operate on either 110 or 220 volts. The machine has a 110 cord coming out of it, so all you've got to do is plug this adapter in, and then you can plug it right into 220 volts. So it makes it really easy to switch between 110 and 220. Then we've got the hose for your welding gas or shielding gas connections. You've got some hose for air connection that the plasma cutter uses. And then you've got a bunch of small accessories in here, like some Teflon tape, hose clamps, and the wheel in there for moving your wire. Then back here we've got a combination water separator and air pressure regulator, and that will be used for the plasma cutting part of the machine. That also includes a gauge so that you can actually see the pressure. And then you've got some fittings and a little mounting bracket. Next in line we've got the work clamp and its cable. I tend to call this a ground clamp. That seems to be a nice, very sturdy clamp there. This is the plasma cutter torch, and of course the cables that go along with that, and they even included a few consumables in the kit. But it looks like it's basically ready to go. Just plug it in and work with it, because they've got everything installed on this torch that you should need to get started. This is the stick holder for when you do stick or MMA welding, and it seems to have a pretty firm clamping action there as well. This is the torch for TIG welding, as well as obviously the cable and hose that goes along with it. And you can see that they've included pretty much everything you'd need to get going other than the actual tungsten rod. This is the last of our cables and torches. This is for MIG as well as Flux-Core welding. This thing's got a nice feel to it in my hand. Looks to be a pretty quality unit. Also includes a couple of extra 30 thousandths and 35 thousandths tips, or 0.8 and 0.9 millimeter tips. And of course we've got the machine itself back here that I'll take a closer look at in just a second. But when you see all of these things laid out, if you want to do plasma cutting, then you've got to have an air compressor to hook up to the machine because it uses compressed air. So if you had an air compressor, and then for MIG as well as TIG welding, you will need a bottle and gas, so something like argon or argon CO2 mix, whatever you happen to need for the exact process that you're doing, as well as a regulator for the bottle. So those are the two other big things that you would need to get going: an air compressor and welding gas, as well as a regulator. But if you had those and then just the basic supplies, for example, you would need sticks to do stick welding or arc welding. You would need either MIG or Flux-Core wire, depending what you wanted to do, and you would need some tungsten electrodes for TIG welding. But if you had those basic supplies and then that machinery that I just talked about, you would be able to get up and running with this kit and those things and do 5 processes. Now let's take a look at the machine itself. Starting up front, you've got this little plastic shield that protects everything behind it. You can flip that up. And then you've got a 4.5-inch TFT display, a home button, and then your control knobs, which not only rotate, but also work as push buttons. They push in. And then on the bottom half of the front, you've got this ventilation area here, and then all of the connections for your torches, grounding clamps, etc. Turning to this side, not much going on over here, just your labeling and then a vent. A look around the back. Here we've got dual cooling fans, the mount for your water separator / pressure regulator for the plasma cutter, your on-off switch, obviously the power cable here, gas connection for MIG, gas connection or air connection for the plasma cutter, and then a little chart with specs that should probably match what I showed you on the box. Now let's take a look at the other side. Over here we've got the door. Just push this down and then you can drop the door, and now you can see your wire, your spool holder here, and the feeding mechanism, as well as your positive and negative connections in here. You may notice that over here there's no gap. It's actually very tight. There's interference. And then over here there's a gap at the top of the door. This is a problem that YesWelder has said they are aware of, and this is going to be corrected for all future units. Again, this is just a beta model or a beta machine that they are sending out to people that get it to review before it's ever released. Now I'm going to go ahead and plug this in and flip the power switch on. This is what I've really wanted to check out because none of my other welding or cutting machines have a digital display like this, and it appears to me that it should make it a lot easier to use, a lot more user-friendly, in addition to some of the controls that they have in here. So I'm going to start out by touching the home screen, and then you can see it allows me to choose any one of these processes here. So I've got settings, and then we've got plasma cutting, lift TIG, FCAW or Flux-Core, MIG, MMA, stick welding, and again back to settings. So I'll go ahead, I don't know what settings is, so I'm going to go ahead and check that, just pressing this button. So you can change the settings from inch to millimeter. I'm more accustomed to inch, so I'll set it there, just pressing this button. There don't appear to be any more settings, so now I'm just going to go back to home with the home button. And let me check something out here. I think I'm going to go to Flux-Cored just because that's what I'm most familiar with. I'll hit select on there just by pressing this in. And then you can see all of the options and settings for that. So one thing that's neat with this machine is if you look right here, you can see that it actually shows you where the ground clamp needs to be connected to do the job. So they're showing you that you need the ground clamp connected to positive for Flux-Core welding. So when you go and set this up, there's no doubt in your mind that you've got it set up right if you just pay attention to the screens. And actually, let me go back to home and I can show you, hopefully, that is different for all of them. They show you exactly how it is. See, when you go to MIG, then you can see they show you that the ground clamp needs to be on negative. So you can definitely check that. That's good for people like me that aren't exactly sure all the time of how everything should be set up for each process without looking it up. I can just look at that screen and that will tell me. So let's go back to Flux-Core. This machine uses synergic control for both Flux-Core and MIG welding. Pretty much what that means is that when you enter some parameters, for example, you can see you've got thickness of wire up here and thickness of material. When you enter that stuff into the machine, let it know what you're doing, then it will try to help you get a good end result by making suggestions and setting some things up for you without you having to do it. Now let me demonstrate that a little bit. I'm going to start out by pressing this button, and then you can see that my wire thickness illuminates up here, and I can choose 30 thousandths or 35 thousandths since I've set it in inch settings. So I'm going to go ahead and choose 30 thousandths. Then I can move over here. This is 2T or 4T. So what that stands for is 2-touch or 4-touch. I generally prefer 2-touch, but basically what this is 2-touch is essentially how most of us would think of anything operated by a trigger, like a welder operated by a trigger. So if I squeeze the trigger, it starts welding, and when I release the trigger, it stops welding. Pretty simple. If you were to choose 4-touch on this menu, then what happens is you squeeze and release the trigger, and it will go ahead and start welding. And it will keep welding until you squeeze and release the trigger again. Now, I'm going to put that back on 2-touch. Then we can go over to material thickness. So here you can see they've got 18 gauge, 16, 14, 12, and 10 gauge. Then it goes up to 3/16, quarter, 5/16, 3/8, and ½ inch. So all you have to do is select the material thickness that you'll be working with. I'm going to go with 12 gauge, that's almost 1/8 of an inch. And you can see that it changes some settings here for me. It turns the amperage up. And it also went ahead and adjusted the wire feed for what it thought I would need. And then you can see over here as well, the voltage has increased. Now, with a voltage increase, you can dial this in a bit. So you can just turn this button and you can see it starts at 17.1 at the moment, and then I can dial it down to 5 volts less than that, so 12.1, or I can move it up to 5 volts more than their recommendation at 22.1. Or I can just leave it alone, and most of the time they say that that should work pretty well. Now let me go over and finish the rest of the settings. Now you've got burn back here, and that's adjustable from 0 to 10. I'm going to leave that on 0. I've actually never owned another machine that allowed me to set the burn back setting here, but I do know that burn back is when you burn the wire. So on the end of the wire you'll have a big ball on the end, a burnt ball, and that usually happens when your feed rate or feed speed is too slow, or it can be if you're holding the gun way too close to the work. But I'm just going to leave that at 0 for now. And the last option up top here is memory. So if I go over there, then this will allow you to store a setting that you like. So for example, if I like this setting, I could store it and then go back to it later, and that gives you 10 memory settings, which you can easily select. So let's see what they got on 2. I guess there's nothing stored in there yet. Well, you can see it changes with some of them. Yeah, so you can set that wherever you would like it, anything that happens to work out for you. And then you've got it right in the memory, and you can see it's already got number 1 stored right where I just was. I'm going to try out MMA or stick welding first because it's the simplest and quickest to set up. So all I really need to attach are the electrode or the stick holder and the ground clamp or the work clamp. And then I'll need some sticks. So I've got E6013 welding sticks here, or rods here. And then of course you're going to need your safety gear like welding gloves and a welding helmet. I've never done stick welding and I'm not sure where I need to connect my clamp or my stick holder. So I'm going to let the machine help me out here. I'll go in and choose my rod, which is 60 series, and I can see that with that chosen, it's telling me that I need to connect the ground clamp to the negative side. I like to turn the machine off and even unplug it from the wall. Again, 100% safety. When you look at the machine, you can see there's a positive and a negative terminal right here. I know that I need to connect my ground clamp to negative, so I'm just going to put that in with the little nub facing straight up and then give it a twist so it's locked in. Now I've got my stick holder, and since the other one is in negative, I know that's got to go in positive. So again, insert that and give that a twist. To finish setup, I'm just going to go back into MMA. I'm going to verify that I have 60 series rods selected, and they are set at 330 seconds, just like what I have. And the machine tells me that I want to work at 80 amps, so that's where it has set itself. That agrees with what the rods say on the package, so I'm going to go ahead and use those settings. Now I just need to get my gear on and try it out. Okay, well, like I said, this is new to me. So apparently you have to push the very end of the stick up against there where it's bare metal. There we go. I'm trying to hold it right up against there, and it seems to want me to back it off a little bit, I think. So let me try that again, now that I have some mild clue what I'm doing. There we go. So that's where I started. It actually didn't look as bad as I thought, but I was confused. I was trying to just hold this stick onto the material and waiting for it to start welding, but it's a lot like a lift TIG would be, where you touch it and lift off, and once you lift off, then the arc starts, and then you can start moving it. So that's my first time ever doing MMA or stick welding, and all things considered, since I never even looked up any information about it, I would say that that went pretty well, and definitely the machine helped me out by getting me in the range for the right settings. I'm just going to go over, I think, and try one more pass just on top of the metal, just to give it one more shot. Touch and lift off, and then see how that goes. Touch, lift off. There we go. And just lift to stop. So I'm certainly not doing anything great here, but I got started really quickly with that, and actually that little section of weld there looks pretty darn good for 2 minutes into trying to stick weld. I've got a lot to learn with stick welding, but I've got to say, it was very quick and easy setup. The machine helped me out with the settings. All I've got to do to clean this up are to put my rods away, and then 2 quick disconnects here, twist to unscrew, unplug the machine, and it's all ready to go, move along to whatever I wanted to do next. Now I'm going to switch over from the process that I had never done before to the process that I've done the most. So I'm going to go from stick welding to Flux-Core welding. Flux-Cored welding is the second of the gasless welding processes that you can do with the MP200. The first obviously being stick welding that I just showed you. So both of these carry their own shielding agent right with the filler agent. So in the case of the stick, that makes it pretty obvious. You can see that you've got your filler rod there down the center, and all this stuff caked on there is the shielding agent. It's not so obvious when you look at a flux-cored wire, but it is also carrying that flux or that shielding agent along with it. Both of these are really good for what I'd call maybe adverse conditions. So perhaps you've got a piece of equipment out in a field somewhere, or something outside, you can't move it inside, there's a little bit of wind blowing, maybe you can't get everything perfectly clean to the standard that you'd like. These are going to be a little more resistant to problems when you have that kind of conditions. So with that said, let me see if I can get this thing set up so I'm ready to do some flux welding. This is where the wire is going to install, and I've got to make some changes, so I'll go ahead and open this door. The first thing that I'm going to take care of is to swap the cables that are on these terminals with each other. So the cable that's over here on the positive is going to go to the negative, and the cable that's on the negative is going to go to the positive. And the reason that we're going to do that is because most processes that we do, like MIG for example, are DC electrode positive. So that means that the ground clamp goes to negative and the torch goes to positive. In the case of Flux-Core welding, it's DC electrode negative. So the torch goes to negative and the ground clamp actually goes to positive. So that's the reason that we've got to switch these two. It's pretty simple. These are just thumb screws. So unscrew each one. And then remove that. Put the negative over there. Positive over here now. And on this side, the cable's in the way a little bit. I may have to move this around somewhat because the way it sits right now, it doesn't want to sit flat for me. So let me take that back off. I think I actually need to move this up a bit. It will go much better if I positioned it this way. Alright, much better. Now I need to swap out the wire feed roller in there because what's in there from the factory is the MIG feed roller, and I need to use the Flux-Core feed roller. And I'll show you the difference once I get it out of there. But the first thing I'm going to do is pick this up and pull it toward me, and you can see this whole assembly pops up, create some slack in here, and then I just need to unscrew this cap or bolt, whatever you'd call it. Then the feed roller will slide right off. This is the roller for MIG wire, and this is the roller for Flux-Cored wire. So you can see both have two sets of grooves. Each one has a 30 thousandths and 35 thousandths groove, or 0.8 and 0.9 millimeters. But the big difference here, if you look at the MIG roller, you'll see that it has smooth grooves. Then when you look at the Flux-Cored roller, you can see that they're kind of jagged or almost serrated looking, and that works better to feed the Flux-Cored wire. So that's the one that we need to put on here. I'm going to be using 30 thousandths of an inch thick wire, so I need to align it so that this 0.8 millimeter marked side faces inward. So when I install it, I'm going to flip it around and I'm actually going to see the 0.9 marking out toward me. The other thing to be aware of is that you have a keyway here, and then there's a key on this little shaft, so you just need to align those and it should slide right on into place. Once that's on, then you can reinstall your cap. Doesn't have to be super tight, but get it snug. Now I'm going to install my wire. I've got a 10-pound spool here, but you could use a 2-pound spool. You would just have to remove some of this adapter to do it. So to loosen, you actually go the opposite direction that you'd normally think and turn this to the right. And then this wire can slide on over there. And then you're going to have to turn it to the left to install it. I usually turn it to the right first, then back to the left. Just easier to start for me. Now I'll find the end of my wire here and free that up. Just going to trim it off so I've got a straight piece. Cut that bend out of there. And then the wire needs to be pushed through here, and you're trying to push it across the top of the roller into this side here. And you can see I've got this assembly flipped up out of the way because I don't want any tension on that right this second. It's much easier to start that way. And I'll continue to feed that through until I see the wire coming through the front of the machine. Now you should see graduations on here. You can see 5, 4, 3, and 2 and 1 are under here. So I'm going to back this off until I can see the 1. That relieves the tension. There's the 1. Now I can flip this down. Then this piece will flip down. And you kind of hold it. and then flip that back up. And this is very, very loose. I'm just going to put a little more tension on there right now, but I'll do that adjustment later. Next, I need to prep the flux and the MIG torch. So the flux and MIG torch is really easy to identify because it is the only one of the accessories that has this really large connector on it. But what I want to do first is go ahead and remove this, just unscrew it, and then there's a tip in the end of here. One thing that you'll need to do is look at it. You should find some numbers, and there's a 30 thousandths or 0.8 tip and a 35 thousandths or 0.9 millimeter tip. So you need to use whichever one is appropriate for the wire that you're going to be using. I've actually already got a 30 thousandths tip in there, but I'm going to go ahead and remove it anyway. It just unscrews, because when I start wire through this in a minute, I like to have that out of the way. It's just one spot that it can't bind up. Now I'm ready to install the torch. You'll see this one section that sits the most proud. You want to feed the wire right into the center of that. Push it on, and then there's the 3 other prongs in there that are going to have to align. Get those into place, and then you just thread this connector on there. I've turned the machine back on. I'm navigating to Flux-Core. And now I'm going to go ahead and check everything in the top row. That's on steel 30 thousandths of an inch, which is correct. I want it on 2-touch. It says 18 gauge. I'm going to move that up to 12 gauge for what I'm doing. Burn back is fine, and I don't need memory, and I'm not going to adjust the voltage that they've got recommended there. Now I need to feed the wire all the way up till it comes out of my torch. So all I need to do for that is to push this button on the left side and hold that in. And you can see it starts feeding the wire. And you can actually feel when the wire gets close. There it is. Let a little more come out of there. The tip will slide over that wire and then thread back into the torch. Put this back on and screw it in place. To finish setting up the wire feed, I need to set the tension. So the more I screw this in, the more tension I'm going to put on the wire feed. If you don't have enough tension, what happens is you'll get slip. It could slip when you hit the trigger and doesn't feed it at all. And it could be that it just slips sort of intermittently, so as you're welding, you'll see that the weld is trying to start and stop because this is slipping. If you put too much tension on here, you can deform a wire, especially with MIG wire, kind of crush it. Or one thing that I think every welder that's ever done any sort of wire feed hates is it does what they call bird nesting. So if anything stops the wire on the torch end, like something gets jammed up, then instead of slipping down here, what happens is it keeps feeding wire and it just creates this big bird's nest of wire. You've got to cut this, pull it all out of the torch, so you waste a bunch of wire, and then you've got to restart everything and set everything back up again. I'm going to use a simple pinch method to set up the feed tension. There are multiple methods to do this. You can look them up on YouTube or just Google them and find all sorts of ways to do it if you don't like this one. But basically all I've got to do is have some wire coming out of the end of my torch there, and then I'm going to pinch that wire. I'm going to pinch it fairly hard to put some pressure on it, but I'm not trying to pinch it as hard as I can. Then I will depress the trigger on the torch and watch what happens here to see if it slips or if it goes. So that's trying to push my fingers. That's actually pretty good. Let me back it off a little bit. I'll show you hopefully what happens when it slips. So let me pinch this again. See it kind of being jittery there and slipping. You don't want that. So you want to keep adjusting it just to the point that it's not slipping. That looks pretty good for me. slipped a little bit. Let me give it a little more. There we go. Now, just trim off the excess wire. Just like before, straight in, and then twist it to lock it in place. Everything's ready, so I just want to go back through, look at my screen real quick. I'm at steel 30,000s, 2-touch, 12 gauge, and everything else I've left alone and let the machine do that, so I should be ready to weld. It looked like it went pretty well to me, sounded pretty good. I'm pleased with that for letting the machine do all the work for me pretty much, aside from just setting the wire thickness and the gauge of the metal. I'll go ahead and do one more pass right across the top of here just to give it one more shot, and then I'll get you a closer look at this. Here's what they look like cleaned up. You can see this is the first pass where I joined two pieces together there, and it looks okay. Most of the reason that it doesn't look great is just my fault. Again, I'm not a professional welder, and I never claimed to be awesome at welding. And then here's the pass just across the top of it. Doesn't look too bad to me. What I'm seeing is that the machine does a good job. As with pretty much everything you're going to see here, it's the user that could use more practice or could do better. So far we're 2 for 2. I'm happy with what it's doing. Now I want to kind of break this down because I'm going to move on to TIG next, so I need to switch things around. First I'm going to go ahead and remove my ground clamp with just a twist. Now I'm going to relieve the tension on here just by flipping that down, getting this up out of the way. And with the tension off of there, I'm going to turn this spool and pull the wire back through. You could just cut it off, but then you're wasting all of that wire. And that's what you don't want to do. You want to go slower at the end normally, because otherwise that happens, and then you've got to get that all tightened back up, take the slack out of it. If that happens to you, just unroll it until you get all that section out that's kind of sloppy on there now. And then hold some tension on it and reel it back in. And I just need to go ahead and loop that through here. And now I can unscrew this and remove my spool. Any other process on the machine is going to be DC electrode positive, so get that out of the way, and then I need to go ahead and flip these two wires back. And finally, I can just unscrew this torch and pull that out. Next, I'd like to try out the TIG function of the MP200. So I need to hook up my work clamp and my TIG torch. And I know that they go in the positive and negative here, but I'm not exactly sure which way they hook up. So all I've got to do is go here to TIG. And then, once again, right on the screen, it shows me that the ground electrode hooks up to the positive, and then I will need the torch to the negative. I'll start with my torch, which is going to the negative. Put that in, twist. And then the ground clamp goes to the positive. Put that in and twist. Unlike stick and flux core welding, TIG welding does require the use of a shielding gas. So I also need to hook this up to a tank of argon. I've got a bottle of 100% pure argon set up on the welding cart with my YesWelder TIG 205DS. So I'm just going to roll this over, and then I'll be able to make the connection right to my regulator. And this should just thread right into here. And then I'll just snug that up a little bit. I'll turn my bottle on. And then I can open up this valve on my TIG torch that will allow gas to flow through, and then I'll be able to see how much gas is flowing in my regulator and adjust that if I need to. So I'll just open that up. Gas is flowing. That's a little high. I'll adjust it down to about 10 liters per minute, something like that. Now I can shut that off. The last step will be to get the torch set up, but before I do that, I've got a 3/32 2% lanthanum, that's a blue color coded tungsten electrode, and I need to grind the tip of that. To set this up, I'll start by screwing this in till it's snug. And they include 3 cups. I'm just going to go with the middle size. They've got a 4, 5, and 6. I'll use the 5. And that will thread onto there. And then you've got these collets. They come in different sizes, so you need to check them out. I'm using a 3/32 tungsten electrode, so I need to find the one that says 3/32 on it. There it is. And that will drop right into the back of there. Then I can go ahead and get my rod, pointy end that I just sharpened, going through like so. And then I'll need the cap. So I'm going to adjust this, back it off to get the stick out that I want. And then I can put my cap on. I'll have to readjust once it starts to snug up a little bit. And then go ahead and tighten that up. And that's the torch setup. I'll enter lift TIG, and then you can see that this is both the easiest and the hardest of the processes to set up. The reason is, I've got one adjustment here, and that is to dial my amperage up and down. Notice with a lot of the other welding processes that I've shown you, you'll have the menu up here, and I could pick the wire, or in this case electrode diameter, and you'd be able to pick material thickness and so on. You have presets. With this one you don't get that. You just have to know where to dial it in for your material. So I know that I want this somewhere around 90 to 95 amps for what I'm going to do with 1/8 inch. I'll just go ahead and start at 92 amps. If you have no idea, one thing that people use as a guideline commonly is to say that for each 1,000th of an inch of material thickness, you use 1 amp max. So if this is 1/8 inch, that's 125 thousandths of an inch thick. I would go a max of 125 thousandths. But most likely, it's the age of the internet, so what you're going to do is go online and you can look up charts and other information. The other thing that you'll need when you TIG weld is some sort of filler material. I'm just going to be using 1/32 when I do use it. But I think I'm going to start off by just trying to get used to it and see if I can make a pass right across the top without filler. Because I am very, very new to TIG welding, period, and tend to get lousy results as is. And I've also never done the lift arc or lift style of TIG welding. So there are 3 basic styles. There's scratch start, where you have to scratch across there to get it to start. Lift TIG like this. What you're supposed to do, as far as I understand it, is touch down and then lift off to start the arc. And then when you're done, you'll just lift off to end it. And then there's high frequency start, where you typically have a pedal or a switch, and just when you're close you hit the pedal or the switch to initiate, and then it'll go ahead and start when it's close. But again, this is lift arc. So high frequency start, the reason that that's not included according to YesWelder is because it is cost prohibitive, and they want to try and create a unit that is good for a lot of budgets. So they don't want this to be a really expensive machine. They're trying to keep the cost reasonable so that everybody can afford this. So before I start, I've got to go ahead and turn my gas on here at the torch. Open that up. And then we'll see what happens. I'm going to lift away and end it. And then I can go ahead and turn my gas off. Probably got some improper heat settings that might be a little hot for trying to use it with that kind of weld, but it doesn't look too bad, and it actually was pretty easy to start. I think I got too close there. I'm doing something wrong. First time it was easy, now I can't do it. There we go. Put a little heat in there. See if I can figure out where my rod is. I can't even see it. There it is. And I did a pretty awful job at that one as expected. Well, I didn't really get the pull going until the end, so I think I'm going to turn this up just a little. I'm going to switch this up to 95 amps. Just a little more heat in there. And I'm going to retry the beginning section, see if I can make it look a little better. Okay, so I still did terrible, but I did at least figure this out a lot better than I had before. I went over these real quick with a wire wheel so we could take a closer look. This is my first attempt, just with no filler rod going across here. You can see that actually doesn't look too bad, and that was on 92 amps. Then this was my attempt to weld this seam, and that didn't go too well. By the time I got all the way over here on the first pass, I finally got the puddle going the way I should have in the first place, and that doesn't look awful. Certainly not great either. And then the second time around, I sort of made more of a mess of it. I mean, it's stuck together, but you can see I was missing the mark. I'm way over here with the puddle when I should have been over here. But the important part here is that you can see that the machine is capable. Now on to what I've learned about this and how to get the lift start started. So initially I was trying to come in mostly straight on at the top, and then I would touch it and it keeps getting stuck, and I couldn't figure out what was happening. It's hard to pull away. And I think after it does that quite a few times, it's probably a good idea to go ahead and regrind the tip real quick of the electrode just to make sure it's clean. But what I eventually figured out was that you really need to come in at an angle. And when you come in at an angle, it's going to start easily, and then you can pull it up and adjust your angle as you need once that arc is started. But coming in straight on doesn't work so well. Angle that quite a bit, and then straighten it out as you need after you've got the arc going. And that made a huge difference for me. I'm ready to move on from TIG welding, so the first thing I'm going to do is close off my bottle, shut the gas off. I'm just going to purge the line, don't really need to, but just open this up, see if there's anything in there to get out. Shut it back down. And then I can remove my fitting from the regulator. And it would help if I tried to turn it the proper way. Now I can twist to remove my ground clamp, and twist to remove the torch. And the torch can either be stored like this, or you can break it down if you'd like. Breaking it down is very simple. Let's go ahead and remove this end cap. The rod will come out of there. The collet. Unscrew the cup. And actually everything's coming out together right now. There we go. And then unscrew this. Next I'm going to move on to plasma cutting. I would have done MIG welding next just to finish up all the welding processes at once, but as I told you earlier, I've never done MIG before and I didn't have any MIG wire on hand, so I had to order that. That'll be here real soon. But rather than wait, I'm going to go ahead and move on to the plasma cutting, which will mean first I'm going to need to set up my combination pressure regulator and water separator. Here's the stuff that's included with the machine that I'm going to use to set up my pressure regulator. So I'm going to use some hose, the air hose that they supply, obviously the regulator and water separator itself. You've got a pressure gauge that mounts to that, a mounting bracket. Going to use a couple of hose clamps. They actually supply 5. I should only need 2 for what I'm doing, and 1 of the 2 brass barbs that they supply, and then of course the tape. So when you look at the regulator, it should be mounted this way. You'll see an arrow up here, and that arrow points in the direction of airflow through it. So this is going to be the inlet and this is going to be the outlet. For the inlet, to make this easier, I'm going to use one of these connections that I have. This matches what I have on all of my other air tools, and if I install that in here, it will make it very, very quick to hook this up to my air compressor. I'm going to install this fitting first. So again, make sure you check the arrow on there, and this will be the inlet side, the side where the flow begins. Before I put that on there, I'm going to go ahead and wrap it with some of the supplied tape. And when you do this, you want to make sure you think about, when you thread this in, which way the tape will be facing. So if I'm threading this in this way and the tape faces this way, as the tape comes up on the threads, it's going to want to peel the tape back or leave it in place, and this will keep moving. But if I do it this way, then the tape will go along with it. So you want to think about that. And the other thing is, don't put any tape on the last couple of threads. That way the tape doesn't end up in the rest of the system. When you tighten these up, you want to get them snug, but be careful. Try not to hold on to the plastic down here or up here. Try to hold on to the body the best you can when you're tightening it, because you don't want to break anything off. Also going to wrap the outlet connection. There's not a whole lot of thread depth on there, so you may have to kind of fold it over to try and keep it away from the very end of the threads. And this one is a 13 millimeter. Again, I'm going to make sure I hold the body when I start to tighten it. Initially, I think I said you'd want to mount it this way on the back of the machine. That would make the most sense to me, because you'd have your air connection here on the outside of the machine, and this would be headed right to your gas connection on the machine. However, I wasn't paying attention, I guess. This is where your gauge needs to be set up, and this is just a plug. Now, you could probably remove that plug and transfer it over here, or find a plug that fit in here if you'd like, if that one doesn't. But for now, I'm just going to go ahead and set it up like this. I'll take this plug out of here. Just going to pop it out. And then this pressure gauge will screw into the back of there. Again, I'm going to wrap this with tape as well. Now this one I'm using an 11mm wrench for. Next, I want to mount the bracket to the machine, so I'm going to go ahead and back off the nuts from here. Now I can install this bracket, and when you install it, you should see that there is a prong that faces downward. You don't want that facing up, you want it to face down. Just slide that over, and then reinstall the nuts. I'll snug these up fairly gently with an 8mm socket. Going to remove this red nut from the top of the regulator and separator. Pull that all the way off, and then this will slide up here. And there's a little indentation in the front that matches up to that prong. Slide it up to there, and then go ahead and install this nut hand tight. Next, the outlet of the regulator needs to be connected to where it says cut gas on the back of the machine. And you're going to use this supplied hose to do it. So I'll start off by putting a hose clamp and a piece of hose over this barb. And I can tighten that up with a 7mm socket. You don't want it so tight that you're trying to cut through the hose, but make sure it's nice and snug. Now I need to figure out how much hose I'll need to reach this connection. And when you do this, you want to make sure that you don't make very tight bends, because if they're very tight bends, this kind of hose is going to kink. You don't want that to happen. So give yourself plenty of room with the bends. I'm going to say about there is good. So I'll cut my hose off there. Again, I'll install a hose clamp and the hose. Just push that onto the barb. Tighten up the hose clamp. While I'm working in the back of the machine, I'm going to go ahead and check the regulator, make sure it works, and also dial it into where I want it for the first cut that I try. I'll hook up the air compressor to this side. Then I'll just pick up the top, and I'll rotate it clockwise to increase the pressure until I see it where I want it. Then I just push this back down until it snaps. Now for plasma cutting, I need to connect my ground clamp, as with all the processes, and then the plasma cutting torch. The plasma cutting connections are the only ones that have their own labels unique only to it. So over here there's a label that shows a ground clamp. That's where the ground clamp goes. And then you can see the torch here, and this one beside it. Those are both of the connections from the torch. Starting with a ground clamp, insert and twist. Now for the torch, we've got these two connections. So this one, you just align the two little holes in there, and you'll also see there's an indentation that you line up with the socket in there, and then you thread this little nut on there and screw that into place. And that just needs to be finger tight. Then this just threads onto here. Again, just hand tight. The plasma cutting torch comes out of the box already set up and ready to go. It's got a 1.0mm nozzle on there, and that appears to be the same size as all the other consumables that are included, so there's really no need to mess with it. I'll navigate to plasma cutting, go in there, and then you can see we don't have a whole bunch of settings or recommendations for this. So if you look up in the top corner, we've got pre-flow here, which starts the air moving before you start cutting. I'm just going to go ahead and add a half second of pre-flow. And then we've got post-flow, which keeps the air moving after you've cut. And I definitely know that that cools down the tip or helps to keep it cool. So I'm just going to give it 2.5 seconds of post-flow to help cool the tip. And then again, we've got the 2-touch or 4-touch and the memory settings. Other than that, the only thing we have is an amperage And we can dial that in with this dial on the left. You can see it goes down to 20 and it goes up to 30 for me. And I believe it only goes up to 30 for me because I have this on 110 volts. So I don't have 220 volt power here in my garage, so the only way I can test it is on 110. If you've got 220, it should go up even higher. But I'm going to dial this back to 20 because that's where I want to start for cutting 1/8 inch steel. I've got my air supply on, my machine set up, and I've got my ground clamp or work clamp attached to the metal. So I'm going to go ahead and see if I can make a cut. And my goal here will be to keep this tip about 1/8 of an inch above the metal that I'm trying to cut. I'm just getting a little pop. I'm not sure what's up with that. Let's see if maybe I need the ground clamp in a different spot. There it goes. Let's see what I'm doing here. Okay, I'm going to start my flow and push down. There we go. Well, I got it to start. I don't know exactly what I do different when it starts and when it doesn't. Let me try turning up the amperage. So I'm going to go ahead and just crank this all the way up to 30 and see if that makes any difference. Cutting. No, now we're not. I don't know exactly what is going on here. And it shut off again. And I seem to be having an easier time at 30 amps than I was at 20, but still not wanting to go. I'm just going to hold it right on there and see if that changes anything. Okay, that works. I've got the machine stepped up to 30 amps and I set the air pressure up to about 40 psi. And I'm just going to see if it will cut through this or not. These are two pieces of 1/8 inch steel welded together, so basically 1/4 inch steel. I'm really not sure why it keeps doing this. Unfortunately, I think I know what's going on with the plasma cutting function. Shortly after I got this unit, YesWelder sent out a media kit, which is for people like me that are getting the beta version, and it's got some info about the launch and anything that they think we should know. Within there, they pointed out two known issues in the beta version. One, I showed you earlier in the video, was some fit and finish stuff with panels. The other one is an issue with a plasma cutter where it may not work at lower voltages. Initially they were saying that it may not work if, say, it's specified at 110 or 220. If it gets to, say, 100 volts or 200 volts, then it may not work. However, now they have updated it. I got in contact with them and they've updated it and said that it's best to use it on 220 at 40 amps. So apparently it only works fairly well at higher voltage and higher amperage. Unfortunately, I don't have 220 volt here. I actually brought it inside and I was going to hook it up to the 220 receptacle where my dryer is. Unfortunately, then I realized there are two different 220 sockets that are common here. One is 220 30 amp for dryers, and that's got a different receptacle than 220 50 amp for welders. You could get an adapter, but it's only a 30 amp circuit. They want it to run at 40 amp, so I'm not going to spend the money on an adapter to likely just pop a breaker anyway, trying to run it at 220 40 amp. But anyway, that seems to be what's going on with the plasma cutter. I really wish I could have tested it out, but it's just not in the cards, I guess, for me. The good news is YesWelder has sent beta models like this to myself, as well as professional welders that really know what they're doing. And with real world and extensive testing, they should find any flaws that come up with the machine. So they have said that everything will be fixed by the time it is actually a production model when you could buy it. So hopefully, reaching out to the community like they have and allowing all of us to test it will actually make a better product. To move on from plasma cutting, I'm first going to unhook the ground clamp, and then I can do the torch. Let's start with this one. Let's see if I can get back there. Okay. Then I can spin this around and disconnect my air supply. All of this can stay attached to the machine. My MIG wire just came in, so I'm going to go ahead and set this up for MIG. Now I'm not going to show you the whole process of installing the MIG wire because this is essentially the same as installing Flux-Core wire. I'll have to change this wheel back out down here, which I can do real quick because, again, the Flux and the MIG wheels are different. Slide that off, and I'm going to set it up for 0.8. Find that keyway. There we go. Oh, it would help if I move that. And then screw this back on. So that part's just as simple to set it up with a MIG wheel as it is with a Flux-Core wheel. And I'll have to get this little spool on here instead of the big spool. So I will show you that part, because this is different than mounting a 10-pound spool. Obviously this little 2-pound spool is not going to slide over this big adapter, so I've got to remove the adapter. It's got a 13mm nut in the center there, and then what I need to do, there's a spring behind it I need to push in while I loosen it. So I'm just going to press in a bit, and then I can loosen the nut. If you don't press in, then the nut's not going to loosen. And it is spring-loaded, so just be careful not to let it fly off and lose it. Go. So take off the nut and the washer. I'll just slide this whole assembly off, and then I've got a spring that was sitting in there and another nut. Now you can see the small rod in here that matches up to the 1 and 2 pound spools. So that just slides on, and then just like it came off of the other, got a washer, a spring, another washer, and a nut. Now I'm going to go ahead and press in a little bit and tighten this up. I want to take the play out of there, but it doesn't have to be super tight. I want to make sure, see, there's no play, I can't move it in and out, but it also rotates fairly easy. In fact, I might actually back that off just a little bit. There we go. I really don't want a bunch of tension on it there. From this point on, it's just like setting up the Flux-Core wire. I'm going to go ahead and get it fed through my roller mechanism here, out the front, and then I can set up my torch and get the wire fed through there and set the tension. But again, I'm not going to go into great detail with this for you. I want to install my ground clamp, so once again I'll just look at the screen and it shows me that the ground clamp needs to be connected to negative. The other thing that I'm going to need before I MIG weld is MIG gas, and you can see right on the back here next to the cut gas there is a receptacle here for MIG gas. So they include a cable or a hose for this, and I can just go ahead and thread that into there. This is 3/4 the connection on the machine, and the hose is 5/8, so I'll hold the connection on the machine and then snug this up. Then I can take the other end of the hose and attach that to my bottle, or actually the regulator's connection. And the only gas that I have here is 100% argon, the same thing that I was using before. That may not be the best choice for what I'm about to do, but it should work well enough just to see how the machine works. And then I'll need to turn that on. And of course, just like before, I'll have to make sure this is regulated properly. And I can just hit the trigger and make sure that this goes up to where I'd hope. Looks good. Now I can go through and select all my parameters up top there, allow the machine to use its synergy control, and help me come up with settings. So first, we've got the gas. We've got 100% argon, 80%, 20% argon CO2, 75, 25 argon CO2, and then 100% CO2. But as I said, I've only got 100% argon. My wire is steel 30,000, so it's got options you can see for stainless or for steel. So I'll go to steel 30,000. That's 2-touch or 4-touch. Material thickness, I'm going with 12 gauge again. It's got the same settings as I had for Flux-Core. And then again, we've got burn back and memory settings that I'm going to leave alone for now. So now the machine has set me up saying I'm at 80 amps, 26 feed rate, and 13.8 volts. I'm just going to leave that alone and we're going to see how that goes. Okay, let's see how this goes. I'm going to start off with a pass right across the top here. Really piling it up on there, and you could hear it didn't sound that great. My understanding is that that's kind of what happens when you use 100% pure argon. It's not the best for it. So I turned this up to, let's see, about 15 liters per minute, just to see if that makes any difference for me. Let's give it one more quick pass across here. That doesn't do a whole heck of a lot for me. Let's see what happens with this seam. Voltage seems about right. Feed speed seems like it could come down quite a bit for the way I weld. Though some people, I tend to do a kind of circular motion that works well for me. Normally that's always what I've been used to with Flux-Core. I think maybe if I just zipped it across, that might work better. Not a good idea to put the wood on there. I think if I just zipped it straight across, that'd probably be better for the feed speed, but it'd probably need more volts or amps. I'm going to see if I can get this down a little bit. I'm going to move this dial on the left, and that's dropping my feed speed as well as my amps, but I'm going to try 70 amps. So that drops my feed speed down from what, 26 to 23.2, and then I'm going to turn up the voltage. I'm just going to go ahead and turn that all the way up +5. That's certainly a lot better looking than what I did before. I think I've got enough voltage in there that I can do it, so I'm going to try to turn this down a little more to get the feed speed down. If there's a way to move just the feed speed, I am unaware of it. So I'm just going to go ahead and move it down to 60. That puts it down to 20, let's see. 61 still 20, 62, 61 amps. It's at 16.7 volts. So these are the last two welds. This is actually the last one. This is the one before it. That one I messed all up myself. That's totally my fault. This one actually looks like a good solid weld. Still more buildup than I want, but again, that may be my issue because first time MIG welding ever and not using what I would consider to be the ideal gas for this. But these are the first ones. That's pretty bad. That one's really bad, a lot of buildup. This welding the seam is a combination of too much wire feed speed for me, or I'm moving too slow, and just a poor technique. This one actually looks good. Again, more buildup than I would have wanted there, but it shows nice stacked looking weld from the technique. So clearly this thing can produce some decent welds. Again, another case where I've probably got a bit to learn, and I do kind of wish I could turn the feed speed down alone. If that's in there to do it, I'm unaware of how it's done. Now to remove the MIG setup, first thing I got to do, I'm going to close off my argon gas. And then I'm going to disconnect the hose here from my regulator. Then I've got this connection on the back of the machine. So again, 3/4 inch wrench to hold the fitting on the machine, and then I can go ahead and loosen this and remove it. I'm going to remove the wire, so just relieve tension on this, and then I'll go ahead and wind it back through. I'm not going to go and show you the whole process because it's just like what I showed you earlier with a Flux-Cored wire. Same deal. Then once you've got your wire all wrapped up, remove this, just put a little pressure on there and take that nut off. And then the wire spool will slide right off of there. Put the adapter back on here just to store it, so that'll just slide right over. And then again, you've got a washer, a spring, another washer, and a nut. To finish up, I just need to unscrew the torch, pull that out, and again, remove the ground clamp. After trying out every function of the YesWelder Firstess MP200, I've got to say that I really like this thing. First off, obviously it's a 5-in-1, so it does a lot of stuff with just one unit, weighs about 25 pounds, so it's really easy to carry around. You don't have to have multiple machines to do multiple things, so that's kind of cool. Second off, I like the screen and the buttons to navigate and the dials. It's very easy to navigate. After a few minutes using it, you've pretty much got the hang of what you need to do to get around all the menus and access anything that you need to. So very user-friendly that way. Also user-friendly, I really like the synergy control of the Flux-Cored welding. So with Flux-Core, for me, just dialing in the material thickness as well as the wire thickness, I got a really good result. I was very happy with it. Now unfortunately, when I used it on MIG, it was not as successful. It still did an okay job, but I've got too much wire speed or wire feed speed, so it's really piling up the wire or piling up the weld as I try to use it. Again, first time I've ever MIG welded, so it could be partially my fault, but it would be nice if it had some kind of dial directly for the feed speed so that that could be corrected. On a similar note, I don't think they call it synergic control for MMA or stick welding, but just entering the series of rod as well as the electrode diameter worked pretty well for me for a starting point to get stick welding. And again, that was the first time I've ever stick welded or MMA welded, and it went pretty smoothly. TIG welding with the MP200 went pretty well for me. It's a much more simplistic setup than the synergic control of the wire feeds, where you're basically just dialing in the amperage, but everything went smoothly. My only minor complaint would be that instead of high frequency start, this one does use a lift TIG, so you do have to kind of get used to what it takes to start off the weld. But that said, once you give it a few tries, it's really not a big deal, and then everything goes fine, so no real complaints there. My biggest complaint is probably going to be pretty obvious if you've actually watched this video, and that is on the beta model, the plasma cutting really doesn't work very well. I can get it to work, I could get through some material, but it takes a lot more effort than it should. I do own another plasma cutter, actually made by YesWelder also, and that one works flawlessly. You just zip right through stuff. This one it's stopping and starting. Now again, they have told me if I had 220 it would probably work out better, and also, very important, again I will note that this is a beta machine and they are aware of this problem and it will be fixed before production models are available. And I'm confident that they will do that, again because I own one of their cutters and it works great. But for me, reviewing it as a beta machine would have been really nice if the plasma cutting function worked better than it does. That brings me to 220 volt. I don't have 220, but I do think it's nice that this machine operates on 110 or 220, and they provide an adapter for a standard 50 amp welder receptacle. So for someone like me, right now I don't have 220, I can use it as is on 110, but if I ever get 220 in the garage, then I can plug it in with that adapter, and everything only gets better. It will have more capability to weld thicker materials, and it will have more capability to cut thicker materials. So overall, I really like this thing. If the plasma cutting function worked on the beta model, then it would probably be my favorite machine in the garage. Lucky for you, by the time you can buy one, you're not going to have to worry about that. Related to buying it, I believe that they are launching this on Kickstart, and it's going to be under $500, $499 US dollars, I think. And if you get in early, you can get that price. If you wait, then the MSRP is considerably higher, basically double that. I think it's just shy of $1,000 to get it once they get through the Kickstarter phase, and it's just in regular sales. So if you're interested, definitely check it out. There should be a link in the description. Go take a look at it and get one before the price goes up. With that said, I hope you've enjoyed the review, and I hope you've enjoyed that I've gone over every feature of this thing with you. Thank you for watching. Please hit the like button, share, and subscribe for more.